Hello, welcome to IBCC channel. In this video, we are talking about the OSPF network types. Since routers can connect to various of media in the real world, so to understand the OSPF network type is important. So OSPF network types, there is 5 OSPF network types: the broadcast, non-broadcast multi-access, point-to-point, and point-to-multipoint. Last and also least is loopback. Actually, loopback is not some real network type, but I just list here. Broadcast networks. First, we talk about the broadcast network. So, in the current world, the broadcast network is widely used since Ethernet is dominate the protocol used in the modern world. So broadcast network means a data transport media that supports a broadcasting function. The broadcasting function is only device as a sender sends a data frame onto a transport media on which it directly connects, and all the rest of the device that are connects on this common transport media can receive the data frame that the sender sends. This is from the layer 2 perspective to explain the broadcast means. So the IP reachability between all devices attached to the broadcast network are meshed, since the broadcast network supports broadcasting functions. This is from the IP perspective to look at the broadcast. So the IP reachabilities between all the devices attached to the broadcast network are meshed. So broadcast network segment supports IP broadcast, multicast, and unicast. So let's explain what is the IP broadcast, right? IP broadcast is only device send the IP packets with the broadcast IP as a destination address to a network segment on which the sender directly connects. These network segments can deliver this broadcast IP packet to all the rest of the devices that are attached on that network segment. This is from the IP perspective, explain the IP broadcast. So what is IP multicast? Only device send IP packet with a multicast address as a destination address to the network segment on which the sender directly connects. The network segments can deliver this multicast package to a group of devices that are attached on this network segment and listen on this multicast address. So the last one is unicast. The unicast means a device send the IP packets with a unicast IP as a destination address to a network segment on which the sender directly connects. The network segment can deliver this unicast IP address only to the device that is configured with this unicast IP. So Ethernet, IPX networking, and Apple Talk allow multicast. So the Ethernet, IPX, and Apple Talk are layer 2 protocols. This is from layer 2 protocols possible to see the broadcast. So OSPF adjacency and hello on a broadcast network. So DR and BDR elected on the broadcast network. DR and BDR form the adjacency with other routers that attach to that broadcast network. So that means adjacency form between the other routers to the DR and BDR only. DR and BDR also forms adjacency. For hello packet, hello is a multicast packet on the broadcast network. So that means hello towards 224.0.0.5. Hello intervals 10 seconds by default. So this is about the broadcast network in the OSPF. So next, let's talk about the non-broadcast multi-access. So what is a multi-access means? Multi-access means multiple devices connect to a common network segment and can send and receive data from this common network segment. This is a simple explanation from the layer 3's perspective. Right? So non-broadcast means not support the multicasting function and broadcasting functions. So from the OSPF perspective, that means it can't transfer the package to the destination 224.0.0.5 and 224.0.6. So non-broadcast multi-access usually refers to a network that are partially meshed and don't support the multicasting. So the frame relay X.5 ATM are non-broadcast. Non-broadcast is not often used in the real world for now. Maybe 1 out of 100 times you can meet it in your real works. So the non-broadcast multi-access only supports the unicast, right? So OSPF adjacency and hello on the non-broadcast multi-access network. So special care should be taken when you configure OSPF over the multi-access non-broadcast media. So first, you specify a router that has connection to all other routers as DR. Since usually the non-broadcast multi-access network is not meshed, so you should choose a router that have connection to all the other routers as DR. Specify a router that has connection to all the other routers as a BDR, if this is possible. Define the neighbor IP address. That hello will use this unicast IP address to detect the neighbor. So hello is a unicast hello. Hello interval is 30 seconds by default. So next we talk about the point-to-point. Point-to-point is also very often used in the real work, right? The point-to-point means not only the physical connection is point-to-point, but also the layer 2 protocol from data link protocol perspective is point-to-point, such as HDLC serial link. That's a real point-to-point from the layer 2 perspective. It is supposed broadcast, multicast, and unicast. So routers interface that configured as a point-to-point network type will become the point-to-point type, regardless of what medias that the network connects on. That means you can arbitrarily change the network type on the router's interface, regardless the underlying medium. But whether it works or not, that's a next story. But here, just see you can arbitrarily change the network type on the router manually. So, for example, two routers are connected by an Ethernet cable. It is a broadcast network type by default. From the OSPF perspective, since the Ethernet is broadcast network, it can be changed to point-to-point by changing interface network type to the point-to-point. So why is it changed to point-to-point? Since point-to-point can form the adjacency really quicker than broadcast. So OSPF adjacencies and hello are point-to-point links. Router use a multicast to dynamically detect the neighbor. Two routers form the adjacency directly. No DR and and the BDR elections on the point-to-point link. Hello is a multicast hello. That means a multi-hello destination is 224.0.0.5. Hello interval is 10 seconds by default. So next we talk about the point-to-multipoint. Point-to-multipoint is interesting sense. Router treats this network type as a logical collection as a point-to-point link, even though all interfaces belong to a common IP subnet. So they treat the point-to-multipoint as an individual point-to-point. Right? It's just one ends is one point, other rest is ends is multi-ends. Each interface IP address will appears in the routing table of the neighbor as a host /32 routes. It supports a multicast, broadcast, and unicast on each logic point-to-point link. OSPF, JSON, and hello on the multi-point link. A neighbor are discovered dynamically using multicast. No DR and BDR election occurs since they treat this one as a logic point-to-point link. A hub-side router forms the JSON with every spoke router. So point-multi-point means hub-spoke topology. Hello is multicast hello. That means the hello sent to the 224.0.0.5. Hello interval is 30 seconds by default. This is a longer interval. So point-to-multipoint is not often used in the real world. Here, just good to know it. So next is the last one is loopback. Actually, in the OSPF configuration, you cannot find this under interface. You cannot find the loopback type configuration. However, if the interface is loopback, if enable the OSPF on loopback, the interface type will show as a loopback interface. So only one thing you need to mention here is a router. An OSPF router sees a host thus 32 OSPF routes. For another router's OSPF enable loopback interface. That means another router's loopback interface enable OSPF regardless what the subnet mask is for his loopback interface. This router sees the OSPF routes for the other router's loopback interface as a /32. So this is just remember this. Yeah, that's all about the OSPF network types. Okay, so we can end this video for now. If you think this video is helpful, please give me a thumb up. Thank you.